Okay, what we're talking about today is lesson 3, simplifying expressions using the product rule of exponents. Okay, an exponent can be used to show repeated multiplication. You need to write that down in your notes. Okay, and what we mean by repeated multiplication is that the exponent 3 here forgot to turn on my pen. Okay, the exponent 3 here means that 5 is being multiplied by itself 3 times. So 5 is being multiplied repeatedly 3 times. 5 times 5 times 5. This is 1, 2, and 3 times. The base of the power is the number that's being used as a factor. And hopefully you remember from all of your middle school days that factors are what you multiply. So the number that's being multiplied is the base. So in the case of 5 to the third, what's being multiplied is the 5. So the 5 here would be our base. Again, you need to write that in your notes. The exponent as a natural number shows how many times the base is used as a factor. So that exponent, just like we talked about above, tells us how many times we're going to multiply the 5 by itself. So many times I've seen the mistake of 5 times 3 in this case, and that will not work. Okay, the 3 tells us how many times 5 is being multiplied by itself. So example 1, it says simplify the following. And here we have 6 to the 4th, 8 tenths to the 3rd, 1/3 to the 6th, and 10 to the 5th. And I understand that you all have calculators and that you can easily punch these things in, but in my class, you have to show your work. So what you're going to do to show your work on these is show the repeated multiplication. So, for example, the 6 to the 4th, the 6 is our base, which is being used as the factor, and the 4, for the exponent, tells us how many times we're going to multiply 6 times itself. So I'm going to write out 6 times 6 times 6 times 6. Okay, and when I do that, I'm going to, at that point, get out my calculator, and I'm going to punch in 6 to the 4th, and it tells me that my answer is 1296. Okay, and that actually looks like a 6. So we're going to do the same thing on B. If I have 8 tenths to the 3rd power, that means I'm going to take 8 tenths times itself 3 times. It's good to use parentheses in this case so we don't get confused. So we're going to show 8 tenths times 8 tenths times 8 tenths equals, and then at that point, once again, I can punch it into my calculator. So I have 8 tenths to the 3rd power, and that gets me 0.512 or 512 thousandths. Same situation on C and D. You're going to take 1/3 times itself 6 times. So that means I will have 1/3 times 1/3 times 1/3 times 1/3 times 1/3 times 1/3. When you punch this into your calculator, it's important to use those parentheses like it has shown there. So you're going to put parenthesis 1 divided by 3, close the parenthesis, and raise it to the 6th power. And that gets us this big, huge decimal. If you're using one of the bigger calculators, go to Math, Fraction, Enter, and it will change it for us to the fraction that they're wanting, which is 1/729. And finally, on D, we have 10 to the 5th power. So we know that that is 10 times 10 times 10. I'm not picking up my pen good enough. Times 10 times 10. And you can punch that into your calculator if you need to, but you should also realize that if we have a 10 to whatever power, our answer is going to be a 1 with that many zeros behind it. So 1 with 5 zeros, make sure you show me your comma. The product rule for exponents is something that is going to save you a lot of time, and that states that if m and n are real numbers and x is not equal to 0, then x to the m times x to the n equals x to the m plus n. And that sounds like gibberish, I totally understand, but what this is saying is that whenever you have a power, two powers raised to this, or excuse me, two bases, the same base raised to a power, and you're multiplying them, the base stays the same and we add the exponents. So for example, I have b times b times b, they all have exponents, so my base is going to stay the same. It's going to still be b, and I'm going to take 5 plus 4 plus 2. So I'm going to show my work 5 plus 4 plus 2, and that gets me, equal sign there, b, 5 plus 4 is 9, plus 2 is 11. So b to the 11th. Now on b, for example 2, I have v's and I have w's. So those are not the same base. So I can't combine and get VW. That won't work. But what I can do is I can add the exponents that have bases of V, and I can add the exponents that have bases of W. So for example, here I have V to the 3rd plus the 5th plus the 7th times W to the 2nd plus the 4th. And then all I have to do is simplify. So I have V, 3 plus 5 is 8, plus 7 is 15, times W to the 2 plus 4 is 6. And for your only homework problem for this evening, what I need for you to do is to try to do example 3 on your own, and we will talk about it in class tomorrow.